Hello, Coach Holmes here, and today we're going to be talking about triangles mid-segment and the theorem behind it. So basically, we're trying to determine mid-segment of a triangle. Now, there is some unique things about it. For example, triangle mid-segment theorem basically states that the mid-segment is half the length of the side that it's parallel to. Okay? Now, basically, what a mid-segment is, it's basically taking, so if I draw a triangle here, it's basically taking the midpoint between any two sides and just to make a segment out of it between those two. It's basically a segment between two midpoints of a triangle. That's it. But what's unique about it is that this length right here, we're going to call it xy. xy is half the length of AC. So the formula to it is AC equals 2xy. That's it. So we know that this length is half of AC, or basically AC is double the length of xy. So if we go down here, if I want to find the length, if I want to find all the missing sides, all I gotta do is just keep in mind mid-segment theorem. So for example, EY, that's 20. So half of 20 is 10. So the line that's parallel to this is right here, ML, which I'm just going to say that's 10. Now, this length right here is 10 as well, IL. But check this out. Half of 10 is 5, excuse me. So half of this, so this length is 5 as well. Now, if this is 6, this has to be 6 as well, because we're looking at midpoint here. We're talking about a midpoint of a side. So this entire length has to be 12. And I know half of 12 gives me 6. So the length right here is 6. And that's how we find those missing sides. We just got to keep in mind what's half and what's going to be doubled. So, but luckily, all we had to do was take half of each side. I didn't have to worry so much about finding the length. Now, what we want to do now is for this triangle, B and N, show that TO is parallel and half the length of BN. So I want to be able to find the length of both BN and TO, but also show that they're parallel. So first, let's do the parallel lines. Let's show that they're parallel. So I'm going to go 1, 2, 1, 2, 3. So that's my length. 1, 2. So that's my parallel. So rise over run, it's just 2/3. So if I want to show that this is parallel, this has to be the same slope as 2/3. So I'm going to 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4 over 6. Simplified, it's just 2/3. So I have 2/3 as my slope. So then I got to be able to find the distance for each one. So for TO, remember TO is the point 1, 2, 3, 4, negative 4, 1, and 1, 2, 3. So I gotta be able to find the distance between point T and point O. There we go. Now, but I can use distance formula, which, to be honest, what we can also do is basically make this a right triangle. When I'm thinking about it, I want to make it easier for y'all. Let me do this real quick. Now, because think about it like this. If I have a triangle like this, all I gotta do is just count the sides like this. So I have side of 2, side of 3. Then I can use Pythagorean theorem, or basically 2 squared plus 3 squared equals c squared. So I can just use that if I don't know how to use distance formula. So 2 squared is 4 plus 3 squared is 9. 4 plus 9 is 13. Take the square root for both sides. So I should get the square root of 13, which is 3.605, but I'm going to make this 3.61. Okay. Now, so that's one option you could do, okay, if you know how to use Pythagorean theorem. Now, I do want y'all to try I want you to try the distance formula from point B, which is 1, 2, 3, negative 3, 2, and in, which is 1, 2, 3, 1, 2, 3, 2. So remember, it's the difference between my x, which label this x1, y1, x2, y2. So I'm going to go 3 minus negative 3 squared plus 2 minus negative 2 squared. Now remember, the negative makes it a plus for both of them. So I have 3 plus 3, which is 6. 2 plus 2, which is 4. So I just got to square both of them. 6 squared is 36. 4 squared is 16. 36 plus 16, I got to think about it, is 52. And if I square root 52, 7.21. Now to show that if it's the case, I'm going to double 3.61 and I get closely to it, and that's just because I'm rounded up. But I know it will work. I know this will work because I just rounded up, and the next number would be square root of 53, which is 7.28. Because even if I didn't round up, I still end up being like 1.01 short. So I basically just showed that this distance is half of BA. So now, the next thing I want to do, I'm going to solve for x. Now remember, this length right here is doubled. This length right here is half. So I got to do 2 times 5x minus 1 equals 58. Okay, so the mid-segment, if we double the mid-segment, we'll get the whole length or the side. So I want to distribute. So 2 times 5 is 10x. 2 times negative 1 is negative 2. Add 2 to both sides. And I get 10x equals 60. And what I got to do with the 10? I got to divide it. Divide by 10 on both sides, x equals 6. Alright? So, since x equals 6, we solve for x. So the biggest thing we gotta keep in mind is that for mid-segment, the mid-segment of a triangle is only half of the length that's parallel to it. So we just gotta remember that we gotta double the mid-segment in order to get the actual length of the side. Thank you and have a good day.